Perfect, thank you. Okay, so what you're looking at right now is a picture of the mantle of the Earth. And the mantle of the Earth is a layer that extends beneath your feet from about 30 to 2,900 kilometers of depth. So how come that we have a picture of that? Because, you know, the deepest borehole that we've ever drilled is only 12 kilometers. Well, we have volcanic eruptions to thanks for that. As magma rises through volcanoes, it can grab a piece of the mantle and deliver it all the way to the surface, where one can simply pick it up. And I'll get to pass this around later so that you all get to hold a piece of the mantle of the Earth in your hands. So one could think that volcanic eruptions are a fairly common phenomenon. In fact, on any given day on Earth, there are about 20 of them ongoing. And among the responsibles today, we have Cinnabung and Etna. Chances are you might even have heard about them in the news this week. Yet, common is not the same thing as likely. And this is what I'm going to talk to you about tonight. We're going to focus on the unlikeliness of a volcanic eruption. And in order to understand what I mean by that, you have to look at things from the perspective of a batch of magma. I'm a volcanologist, and I'm going to be your guide for tonight through this very unusual journey through the surface of the Earth. Now, every journey has to start somewhere, and that is a challenge already to begin with. Because besides being green, the mantle of the Earth is also rock solid. Now, we all know from daily experience that if we heat something up enough, it melts. And the mantle of the Earth is indeed very, very hot. However, it is also under a lot of pressure, and pressure hinders melting. So contrary to popular belief, we are not just floating over an ocean of magma just waiting to be erupted. The mantle has the extraordinary ability to melt itself and turn into magma, but only at very specific points. So we've already eliminated the vast majority of the surface of the Earth from a candidate for volcanic activity. Now that we have magma, its journey can start, but it's a very difficult journey through uncharted territory. Because the interior of the Earth is full, so magma has to literally crack its way up. Now, as long as we are inside the mantle, this is not too difficult, because the magma is a lot less dense than the surrounding rock, and so it just rises buoyantly, like the same way that, say, you float in a pool. However, once we get to the crust, things change. The crust has a density that is very similar, and at points even lower to that of magma, and so we say that it acts as a density filter. Basically, it's a trap, if you will. And for magma, this is a very tough obstacle course. And it's one that the majority will never see the finish line of. The vast majority of magma will simply pool somewhere and cool down and freeze in place, basically, and never erupt to the surface. I studied the remaining 10%, the 10% of magma that does make it all the way outside through a volcano. Now, in order for this to happen, we need some kind of trigger. For example, one of the things that happens sometimes and that helps magma be propelled all the way through the surface is exsolution of bubbles. So it's the same process as when you open a bottle or a can of soda and bubbles come up and drag some liquid with it. This is a fairly random event, and however, every single eruption that you see is the result of one such flux. And we don't exactly understand how this works. Now, this is a real problem because it hinders our ability to predict volcanic eruptions and to keep safe the 500 million people worldwide who live nearby an active volcano. Volcanology is a very young science, and so there is still much to be learned. And this is definitely one of the things that got me into it. And my own journey has been quite a challenging one. For once, I've had to move all over the place just to find good locations where it is possible to study such thing as volcanology. And then always come up with new ways to crack problems, if you will, both in the lab and in the field, all while having to deal with the scarcity of funding. And there's been some randomness in the mix as well, such as answering this email that advertised a PhD position in a Midwestern town that I'd never even heard of, but that would become my home for many years later. One way or the other, by the time I made it to Pacaya in Guatemala for my first fieldwork season, I could call myself a volcanologist. my livelihood came from trying to understand how volcanic eruptions work. And at the same time, some magma had made it all the way through the crater and had started flowing down, where I could sample it and study it. So somehow, at the end of this journey that for the magma had begun decades, if not centuries before me, I was there to welcome it at its arrival. A coincidence, quite lucky, but also very unlikely. Thank you so much, and I'm going to pass this around. Please touch it. It's a beautiful thing.